Alright, in this video I will be showing you how to work out exercise 15.8, which reads a certain transverse wave is described by y, the function of xt equals b cosine 2 pi times x over length minus t divided by period, parentheses, brackets, where b equals 7.0 millimeters, l equals 25 centimeters, and t equals 3.3 times 10 to negative 2 power seconds. And part A reads, determine the wave's amplitude. So down here, I wrote the knowns, which is the equation, and then B, L, T, and then I rewrote the equation with all the variables inputted. So which is going to equals y as a function of xt equals 7.0 millimeters cosine 2 pi divided by times x divided by 25 centimeters minus t divided by 0.033 seconds. From there, we know that the amplitude will be the b that we got. It's asking for us the number in meters, so which we simplified to 0.007 meters on part A, which is the wave's amplitude. And then part B reads, determine the wave's wavelength, which will be the other given, which is the length, which was 25 centimeters, and we convert it to meters, which is 0.25 meters. And then it says determine the wave's frequency for part C. So from there, we can employ this equation, which is frequency equals 1 divided by the period, and we know the period is 3.3 times 10 to the negative 2 seconds. So we just input that how we did right here. So F equals 1 divided by 0.033 seconds, which gets us 30.3 hertz. And move on to part D. Part D reads, determine the wave's speed of propagation, which we go down right here, which velocity equals the frequency times the wavelength. So it's 30.3 hertz times 0.25 meters, which gets us the velocity, which is 7.58 meters per second. And part E reads, determine the wave's direction of propagation, and it's in the plus x direction since cosine right here. And that is 15.8.